Hello and welcome to the simpler path to VDI success, persistent virtual desktops that are cheaper and faster than physical PCs. Today we have with us Chetan Venkatesh, who's the CTO and founder of Atlantis Computing. A few notes on the webinar before we get started. The webinar will be recorded, and a recording of that will automatically be sent to you within a couple of days of the webinar. Also, there is a questions box in the GoToWebinar screen where you can enter your questions. We'll both answer questions via chat during the webinar and save a few good questions for the end to ask Chetan directly live. So please enter any questions that you have as you listen to the webinar. We will also have a PDF copy of the presentation available on our website after the webinar. So with that, I'm going to turn it over to Chetan Venkatesh and let him take it away.
Hi, everyone, and a very warm welcome to each and every one of you to this webinar on persistent virtual desktops and how to actually deploy persistent virtual desktops that are not just faster and offer a greater user experience than you would get with the latest, greatest physical PCs, but also how to accomplish that within a reasonable budget in a way that they're actually cheaper to do than with conventional means. This is a topic that I'm very passionate about. It's a topic that we're building a business around here at Atlantis, and so I look forward to sharing with you our insights as well as the internals of our technical approach and our technology into this problem domain over the course of the next 45-50 minutes. So let's get started. When I talk to customers, and I tend to get this wish list from most customers, where customers tell me that they really like the concept of VDI. They want to deploy VDI. They even they even think VDI might be a possibility to become the mainstream way of deploying desktops within their organizations. But cost is one of the biggest challenges that they have. One, they have to make a sizable investment in terms of infrastructure, in terms of retraining their teams to deploying VDI, because VDI requires a fairly significant forklift. You have to stop managing things the way you have in the past and take on a whole new set of tools and techniques to be able to deploy VDI. And that forklift makes it extremely expensive from an infrastructure investment standpoint as well as from an operations standpoint, where people need to be trained in a completely new tool set. The second area that customers really wish things were better was around the user experience, because candidly, VDI is a sort of a second-class desktop for most people. And there's some very good engineering and technical reasons for this that we'll discuss a little later. But fundamentally, most users who've been given a VDI instance in lieu of their physical desktops found that their VDI desktop performs far more poorly and is not as snappy or just gets in the way of getting things done. And so addressing the user experience is second, or even in some cases first on the list of many customers. The third thing that we hear most often is deployment and the risks that are associated with it. When physical PCs have been deployed for 15, 20 years, there's a very well-known set of tools and process for doing that. It's a very mature problem area. And the risks are very well understood. You can deploy a patch, you can deploy operating system images, globally distribute them, and you can maintain the Windows operating system as well as all the application payloads that go with that in quite a straightforward way. But with VDI, we're taking on a whole new different class of infrastructure. We're moving everything to the data center, and we have to deal with multiple components in the stack. We have storage, we have storage fabric, we have the virtualization layer, we have the broker, we have the display protocol, we have the endpoints, and so on and so forth. And each of these can be a fairly complex area. So from a deployment standpoint, there's risks introduced in the interfacing of all these components. They need to be set up exactly right, or you end up with outages, or you end up with suboptimal performance, etc. Finally, what customers want is a predictable, scalable model, which means that when they deploy 1,000 users and they get a dollar value per desktop, which might be X, they want to be able to deploy the next 5,000 users at the same predictable cost model while getting the same sustained performance that they got for their first round of deployment. Now, what's happened with VDI is that it's one of those technologies that works really great in a proof of concept. And as a result, people get very enthusiastic about it. And when they rush it into production and start to scale it out, two things happen. One, the performance starts to really take a dive. And as a result, you start to get a lot of pushback from users. Storage is primarily to blame for this. We'll talk about that more. And the only way to fix that problem is to throw more infrastructure, which drives up the cost. So as you scale up VDI, you end up having these net increases in cost while having diminishing performance, and that's no way to scale an infrastructure or deployment. So we looked at these problems over the course of the last 4 years and came up with a model to solve all these 4 challenges very, very comprehensively. Let's talk about that. Last bit, simplicity. Most customers want some way of reusing their existing process for deploying desktops and applications. They don't want to do this forklift of throwing away everything that they know and embracing the stateless, non-persistent desktop. They'd really like to be able to do VDI with their existing desktop model, using the same images, using the same applications, and the same tools. And so we'll talk about how being able to do persistent VDI while solving performance challenge will actually allow you to transplant your existing process, people, tools, technologies, etc., all from the physical world into the VDI world. So when you look at the VDI marketplace, most typically when people talk about VDI, what they're really talking about is non-persistent desktops or stateless VDI. And in this model, essentially, you face a different way of deploying desktops where you have one common image or an operating system image, and then you virtualize or package up your applications so that they can be deployed on this common image. And you try and basically separate all the different components that make a Windows desktop. You try and separate the operating system from the applications from the user data, and so on and so forth. This requires a fairly long re-engineering of the desktop itself. And then, the more applications you have, the more diverse types of users you have, the more different types of operating system images you have, the longer these projects get. So, it can take anywhere from, tens of months to several years to be able to re-engineer a significant number of applications, images, and user data to be able to get to a non-persistent desktop. And this is one of the reasons why VDI has been taking a black eye over the last 5 years, is the technology that's proverbially next year's technology. It's just extremely difficult to be able to do non-persistent desktops. Now, what is far more straightforward and where people have been successful at limited scales is doing persistent desktops. And a persistent desktop really is nothing more than just a virtual analog of a physical PC. Every user has a virtual PC which is mapped directly to them. It uses the same image as the PC, and it's also managed and maintained the same way the PC is. So, for example, if the PC was managed and maintained with System Center, so is the virtual desktop. And so from the process and the management standpoint, the team that's supporting the virtual desktop sees nothing different. And so they carry over their skills and their experience operations from the physical world into the virtual world. But there is one big challenge. It's extremely expensive from a storage standpoint because these persistent desktops are massive in size. A typical PC might have a hard drive that's about 100, 150 gigs of operating system application installed binaries and user data on it. And so when you start to virtualize them, you need to give that kind of equivalent storage capacity for each persistent desktop. And that means that you can do this at limited scales of a few hundred users, but for whatever reason, when you try and scale this out to thousands of users, the sheer amount of storage you need, 100 gigabytes times 1,000 users means it's very, very prohibitive. There's also the issue of the IOPS, and we'll talk about that in more detail in a second. But the need to drive performance is very, very critical in VDI. If the user cannot get at least a PC-like user experience, VDI is going to be extremely challenging for that user to embrace. And so as a result, trying to do persistent desktops imposes two challenges. One is a capacity challenge, and the other one is also a performance challenge. And until a technology like Atlantis' ILIO came about, it was really, I would say, impossible to be able to do this in a way that was meaningful from an investment standpoint as well as from a user experience standpoint. Now, when we look at the market, we find that 70% of all customers are really interested in deploying VDI as persistent. And it's only 30% of the market, which is composed mostly of smaller organizations or organizations that only see one or two specific lines of businesses benefiting, maybe the use cases offshoring, something like that, that actually look at stateless VDI as the way to go. So the vast majority of VDI that's out there is actually persistent VDI. And they're not able to deploy that successfully because of these problems that I just mentioned. So just to recap what the dilemma with persistent is, number one, cost versus performance. So here's the challenge. If you take a physical PC, it comes with a fairly high performance and cheap storage disk attached to it, which is usually a SATA or a SAS disk. When you virtualize that PC, you're going to take that disk and turn it into something that's in the data center. And that data center storage is an order of magnitude more expensive because you're taking a whole different class of storage and using that for your VDI desktop. So as a result, the storage equivalent cost per desktop is about $2,000 per user. So what costs a few $100s as a SAS or a SATA drive on a physical PC costs several $1,000s when it's in the data center because you're using a whole different class of storage. And so what happens as a result of that is that you typically end up needing to make some trade-offs to try and bring that cost per storage down per desktop, and that trade-off is usually a performance trade-off, and as a result you get poor user performance, poor user experience. I'll give you a little more insights into that as we go along, but this is really a very, very challenging problem. We'll talk about the concept of IOPS in a bit, but the performance trade-off is primarily a result of the chopping of IOPS down, the compromising of IOPS instead in the data center just to bring the cost parameter down to a manageable level. And this creates a very, very large trade-off in terms of cost versus performance. So if you want to get your VDI at a certain cost, you have to give up on performance. Flip side, if you think performance is important to you, you end up bearing a very enormous cost for that VDI infrastructure that is several orders of magnitude more expensive than going with physical PC. Also, this is a high-risk deployment because now you're dealing with the data center and just trying to get the sizing of the storage. How much capacity, how many IOPS, how many disks, what kind of storage fabric do I need, etc. These are all decisions that people in the desktop world are not familiar with, and as a result of that, there's a lot of risk that's introduced. Also, people in the data center, the storage administrators, these are people who have been essentially managing storage for server applications, for databases, for web applications, etc. And when you bring a workload like VDI, which does things that are very, very unorthodox in the data center, where it writes more data than it reads, it issues a lot of random I/O, even they are mostly unsure of how it needs to be sized. And as a result, most VDIs are terribly undersized from a performance standpoint. And as a result, they're going to fail at some particular point. They're all ticket time bombs. Finally, you also need fairly expensive networking bottlenecks. You need fairly expensive networking to get around some of the bottlenecks that are in the data center. You'd need to have fiber channel SAN and storage fabric or 10 gigabit equivalent Ethernet links to be able to move the vast amount of data that VDI needs and generates from the server to the storage infrastructure. Net-net, storage, I would say, is the key underpinning of VDI success. If you can get storage right, and that means getting the capacity right and getting the storage performance right, then you can have a winning VDI solution. So what Atlantis has been doing is pioneering a very different view of how to do VDI by taking a resource that's already available in significant abundance in the data center and reshaping that into a very powerful storage technology. So what Atlantis ILIO Persistent VDI 4.0 does is it takes the RAM that's on the server off the VDI host and turns that into storage. And by doing that, it's able to provide a very, very high-performance storage platform coupled with some very interesting software capabilities that allow you to expand and amplify the capacity available on that RAM to store and power PCs. And that can have a fairly dramatic effect on how you do VDI because, number one, by doing this, you actually get complete parity in the cost of the CapEx as well as the OpEx to that of a physical PC. So now, finally, by deploying your VDI along with ILIO Persistent VDI 4.0 and leveraging the server RAM as storage, your VDI can be on par in terms of cost of physical PC. And you can actually start to do persistent VDI rather than non-persistent VDI. So your management tools and your management operationalization techniques and people and resources all simply map over from the physical world to the virtual world. And so you also get operational alignment and parity with OPEX costs. So that's a very, very big deal. I would actually suggest that the CapEx can actually be even cheaper using this approach rather than buying physical PCs. We'll talk about that a little more. Number two, what Atlantis is doing is essentially turning RAM into storage. And there is no faster class of storage today than RAM. RAM outperforms even the fastest storage systems when it comes to, even if they're built with all flash. And so the user experience that the Atlantis product can drive from RAM as storage is of the highest quality, bar none. And as a result, users want to use the VDI system because it's the fastest desktop they've ever been able to experience. And as a result of that, the VDI goes from being a push model where it's being pushed and forced down the user's throat to now a pull model where users actively seek, experience it, and then evangelize it to all the others within the organization. And soon, that itself creates a great amount of demand for VDI within that organization. Now, the technology is very, very transformatory. There are lots of interesting technical bits in there that we'll talk about. However, it's not just the storage optimization that the Atlantis ILIO product does. It also comes with some very sophisticated tools for automation and deployment. As we talked about earlier, one of the things that the customers have on their wish list is simplifying deployment and making it scalable. And so we have built a complete set of automation within the product that allows you to deploy VDI, soup to nuts, and to do this very quickly, very easily, while eliminating many of the risks that are there in VDI. And because you're doing persistent desktops in the data center, HA becomes a very big factor. And the Atlantis ILIO product comes inbuilt with high availability that ensures that your VDI stays operational even if your hardware fails. In addition to that, we also have the ability to do DR, disaster recovery, and BCP between two data centers. So as you scale out your VDI from 1,000 users to maybe 5,000 or 10,000 users and you're starting to address multiple geographies, you can make sure that you have resilience even at a geo level by getting disaster recovery for your VDI infrastructure between two data centers. But the most compelling part of this model is that as you add more users, you scale out on demand just by adding servers and the Atlantis ILIO software, and not by bringing in more and more storage. And as a result of that, you meet the final part of the wish list that customers had. They want to have consistent performance, and they want to have consistent cost model. And it can't get simpler from that standpoint because your cost model simply is the CapEx of buying servers and additional licenses for the Atlantis software. So let's dive into the technology and talk through how does Atlantis ILIO 4.0 persistent product work? How does it take the server RAM, turn that into storage? So what I have over here is a quick graphic that describes the overall working of the solution. So on the right side, I've got some RAM. This is the same RAM that you get on any IBM, HP, Cisco, or Dell x86 server. So we typically take between 64 and 80 gigs of the memory on a host and turn that into storage. And so, you would want to look for a host that has at least 192 gigs of RAM or more. We'd recommend a 256 gig host being the backbone of your VDI infrastructure, so to speak. So we take the RAM, and the Atlantis ILIO software basically turns that RAM into an NFS data store that plugs into your hypervisor. So there's a piece of, so logically the Atlantis software is sitting in line between that RAM and your hypervisor and turning that RAM into storage. And you essentially provision your VMs on this NFS data store that's coming from the Atlantis software. And as you provision it, the Atlantis ILIO appliance will optimize all that data that is being generated as you provision or migrate VMs over there and store them on RAM. What are those optimizations? Well, there's a type of optimization that we call real-time inline deduplication, another one that we call real-time inline compression, another one that we call fast coalescing, and a fourth one called fast replication. What are these pieces? We'll talk in a bit. But net effect is that all the I/O that's generated by the VDI VMs as they're provisioned, migrated, powered on, users log on and start to generate a lot of activity, all of that I/O and data that is created is processed by the ILIO virtual machine, and only a small fraction of that is actually stored on that server RAM. The combination of deduplication and compression allows us to amplify the limited capacity of RAM that's on a server and turn that into a feasible amount of storage that you can actually power many, many VMs from. So what does that mean? It basically means that we can take 80 gigs of physical memory and turn that into between 2 and 4 terabytes of physical storage. So from a hypervisor's perspective, it sees the equivalent of 2 to 4 terabytes of storage that it can put virtual machines on and run virtual machines on. But what the Atlantis software is doing is actually taking that 2 to 4 terabytes worth of virtual machines and their VMDKs or VHDs and storing that on just about 80 gigabytes of physical RAM. Now, what that means is, so the picture is very, very simple to understand. If you're going to do persistent VDI, you either have to buy storage for the blue graph, which is the total amount of I/O and storage being consumed by the VMs, or you can buy storage for the red graph and buy the Atlantis software that allows you to eliminate most of that I/O and data because of the nature of VDI. So net-net, what's happening over here is that the Atlantis ILIO persistent VDI is dramatically reducing your storage requirements. And we'll talk about the concept of IOPS, but here's the kicker. What we can do is give each desktop in your infrastructure the equivalent, the minimum equivalent of 300 IOPS. And that's 3 times more than you get with a typical physical PC that most office or enterprise users use. And what's happened in the VDI industry, as we talked about compromises earlier, is that most of these VDIs are sized for cost reasons for between 10 and 30 IOPS. And that's the main reason why the user experience is of such a low quality. And so what we've done is we've dialed up the amount of I/O available per desktop by a factor of 10, from 10 to 30 IOPS to a minimum of 300. And as a result, the user experience is just stellar. Applications launch in seconds. Before the user can take their finger off the mouse, the application's already launched. VMs will boot at scale within 15 to 20 seconds. So for example, we have deployments today. Our typical deployment, you can bootstorm 1,000 VMs, and the average boot time of each VM is under 20 seconds. But the most impressive part of all this is that the actual physical storage that's required underneath this is a small fraction of what it would be without us. So that allows us to directly address the storage CapEx and OpEx. We can reduce the storage cost by almost 85% over 3 years. And this is a real example. One of our financial services companies on Wall Street has saved $50 million hard dollars in storage for a 14,000 user deployment. And they've been able to reduce almost a 5,000 disk array down to just 800 disks. And over 3 years, they cut their cost per desktop from $1,172 to just $271. So as you can see, storage really is the bottom of the iceberg. The tip, is the servers and the software. And what Atlantis does is eliminate that complete bottom of the iceberg, the stuff that's hidden underneath the iceberg for you. So let's actually talk a little more about what are IOPS and why are they important. Because this might be a term that you're starting to get familiar with, especially as you start to look at VDI a little more seriously. So the term IOPS stands for I/O operations per second, and it's a measure of the capacity of commands that your storage system can process. Sort of like how horsepower is the capacity of power that your engine can deliver. So a typical storage disk, like the one that you find on a physical PC, has about 75 IOPS capacity. It can process 75 commands in a second. And when we talk about these 75 IOPS, we're very specifically talking about what are called random IOPS and not sequential IOPS. And random IOPS are more important in interactive workloads like VDI. Sequential IOPS are more important in transactional workloads like database systems, et cetera. So we won't talk about sequential now. We're talking about random. And a typical PC has a hard drive that can give you about 75 IOPS. Now, on the other hand, you have consumer technologies like Ultrabooks, like MacBook Airs, where there's an SSD in there, and that can deliver anywhere from 1,000 to 5,000 IOPS. And that's the #1 reason why people love their MacBook Pros and their MacBook Airs or their Ultrabooks, because these things are so fast, and it really is a pleasure to use OS X or Windows on them. And even if you take one of those cheap PCs and that has a 75 IOP hard drive and replace it with an SSD, it magically transforms and becomes faster. And so if you think about it, the real underlying constraints that stops from an average PC from being a great PC is the quality of the storage system underneath it. Yet, when it comes to VDI, if you read the best practices that are being provided out there by most of the people who are interested in selling you storage for VDI, they're telling you that you should be sizing your VDI for anywhere from 10 to 20 IOPS per user. And why are they doing that? Well, they're doing that because if you actually try to size it even for the minimum number of viable IOPS, which is 75, it's just going to be so damn expensive that you're not going to do VDI. So, it's a bit of a charade where there's a disservice being done by the industry to customers, where they're telling you to undersize your VDI storage IOPS because they just want to make it affordable. And so ultimately, if you ask someone who's got one of those PCs, has a SAS SATA drive that drives 75 IOPS, how much do you love your PC? They'd probably say, I don't love it, it just gets the work done. They're not going to be passionate about it. On the other hand, if you ask someone who has a MacBook Air, how much they love their MacBook Air or their Ultrabook, they'd be pretty passionate and express their enthusiasm for how great the product is. And like I said earlier, the fundamental difference is just the storage. So I'm going to ask you a fairly important existential question as a VDI practitioner. If 75 IOPS cannot make a user happy, it's how do you think it's possible that cutting down that IOPS for a VDI between 10 and 20 is in any way going to make them happy or ensure that your VDI is successful? It's just not going to happen. So what we did is we did a very detailed analysis of the amount of I/O operations per second, or the amount of commands that are generated as you launch the typical Office applications that exist in an environment, in a typical VDI environment. So, user comes in the morning, logs in an Outlook, and these are all the applications they're firing up. What you're seeing over there is the application and the peak I/O that it drove, or the peak amount of I/O it generated, not the total I/O it generated. The total I/O would be represented by all the area under the graph. And so if you look at it, Outlook generated a peak I/O of about 975 IOPS and took about, it generated a total of maybe 5,000 to 6,000 IOPS, which is the line under the graph. PowerPoint, took about 1,100 IOPS at its peak, but seems to have consumed about 3,000 IOPS in whole, and so on and so forth. So if you look at the Windows update, that's 4,000 IOPS, but it ran for a fairly large amount of time. I'm going to guess that it's somewhere in the realm of 20,000 IOPS that it actually generated. Now, interestingly, right at the end, even when the Windows system is left idle, it generated a peak of 2,000 IOPS, and while it was idle, must have consumed something like 5,000 I/O operations per second. Now, this was run on a system with an SSD of 1,000 IOPS capacity. So that SSD can deliver 1,000 I/O operations per second. So when I launched Outlook, it approximately took 4 seconds for me to launch all of Outlook. When I launched Chrome, it took about 3.5 seconds for me to launch Chrome because it's about 5,000 or 6,000 IOPS in there. When I did the Windows update, it took me several minutes, maybe 4 to 8 minutes to get that Windows update done because that, 8,000 to 10,000 IOPS is the total amount of I/O commands that were generated. So the net point I'm making is, with an SSD with that kind of I/O, like 1,000 IOs, it still took several seconds to get these activities done. So how on earth is it possible to size your VDI for 20 IOPS per second and expect any kind of user experience that's within within a reasonable area of expectations? If you had a 20 IOP VDI sizing, and you had a reasonable number of users who were simultaneously logging in and launching Outlook, that 975 I/O operations would have to be, would be delivered over a much longer period of time. I'm going to suggest over a period of time that's at least 5 times longer. So if it was taking 25 seconds to launch something over here, it's going to take about 150 or more seconds to launch using just 20 IOPS. Now, when you're just throwing these numbers around, it doesn't seem like a lot, but when you're sitting in front of a PC, urgently trying to fire up Outlook so you can respond to that purchase order, or you can respond to that emergency email where somebody's asking you for information, that's when, you realize how slow that storage system is and how underpowered it is for the VDI environment. And that's nothing. Just consider the situation where you start to patch machines. And if there's a sizable number of VMs in your environment that are getting patched, then the entire I/O capacity of your storage system can be completely consumed just by the patch alone. And that storage system can no longer give you the 20 IOPS per desktop that you're sized for, in which case things get even slower. I've had several situations where customers have called us to help them when their entire VDI environment had completely melted because of one single patch, either to the operating system or because of an antivirus update, and all the users were down. So there's a tremendous concentration of risk that happens in VDI around storage, and if you don't get the sizing right, and that means at least sizing for 75 IOPS per user, you are guaranteed to fail trying to do persistent or even stateless VDI. So what Atlantis does is really eliminates the IOPS problem entirely because we use RAM as storage, and RAM is the fastest kind of storage. Each of our software machines, each of our software machines take the RAM on a server, turns that into storage, and delivers 50,000 IOPS within that host. One of our software instances is installed on each VDI host, and it delivers 50,000 IOPS within each of those hosts. What is 50,000 IOPS? Basically, it's like having a flash array dedicated to each and every one of your hosts. So as you scale up, you can always consistently deliver 50,000 IOPS into each of those hosts. There is absolutely no dependency for storage on physical storage. The physical storage is never in the I/O path. Now, here's the best part of the whole thing. RAM is volatile, so when you put contents of virtual desktops like user documents, etc., on RAM, and you lose that power on that server, you could potentially lose it, but not with Atlantis ILIO, because what it does is it continuously backs up the contents of RAM asynchronously using our intelligent fast replication technology down to a physical storage layer. And as a result, it always keeps the contents of the RAM down on disk. So if you ever lose power, you simply come back from that physical shared storage layer and restore the contents of RAM, and off you go. So it gives you the best of both worlds. It allows you to take advantage of your shared storage, your SAN or NAS, for keeping data very reliably. And at the same time, it disconnects that physical shared storage, your SAN and NAS, from the runtime performance of your VMs and ensures that everything is super fast because everything is running off RAM itself. And this basically makes for very extreme performance. It's faster than a MacBook Air with SSD. Each of your desktops end up actually being faster than the fastest Ultrabooks out there. As I was sharing with you, the boot time of your VMs during a boot storm stays consistent and under 20 seconds, an average boot time of almost 12 seconds. From a user experience standpoint, application launches are instantaneous, and most importantly, you can start to do the right thing from a user experience standpoint by enabling things like fast desktop searching, Outlook email indexing, etc., which are all big no-nos in VDI. If you read the VDI best practice documents out there, they're all telling you disable indexing, disable search, etc., because 20 IOPS, there's no way there's enough I/O to drive all of that activity. Well, with the Atlantis ILIO for in-memory VDI, there's so much I/O available that you can put it all to use, and so you can actually throw all those optimizations away and turn on indexing and searching so that your users have a better user experience. So a little bit more of a technical view of what's happening inside the Atlantis ILIO virtual appliance. So what it's doing is it's taken the VMs that are operating on the NFS data store that the Atlantis software provides and processing it over five different types of transformations, and then storing it on memory, and then replicating it back to physical storage. So what are those 5 transformations? 2 of those transformations, application analysis and I/O processing, are transformations that are done to the read I/O, whereas 3 of those transformations, inline unification, compression, and I/O blender fix, are done to the write I/O. So unlike most storage systems that are just block engines that don't really understand what they're storing, Atlantis ILIO is a content and a context-aware storage engine that is able to optimize both the read traffic as well as the write traffic. So let's talk about application analysis and I/O processing. A standard fan or a NAS has no awareness of what it's storing. So you could be storing a virtual machine or a database or a picture of your vacation in Hawaii. As far as the storage system is concerned, it's just a bunch of blocks. It knows nothing about what's in them and how they differ and how best to process them. The Atlantis software, on the other hand, makes very, very fine-grained, detailed fingerprints of each I/O request made by each virtual machine, and it uses that fingerprint to characterize and optimize the way it services that out. How does that work? I'll give you a quick visceral example. If you have two users using an Atlantis ILIO-powered VDI, the first user is launching a massive spreadsheet because they want to run a sales report off their data warehouse. You want that spreadsheet and Excel to launch, as quickly as possible. At the same time, you've got a user who's typing up an email in the background. You've got a large AV scan that's starting up. In a conventional storage system, it doesn't recognize the Excel spreadsheet launch from the AV scan, and so it simply serves the request in the order that they came. And if there's not enough capacity on the storage, too bad, everybody just has to wait. Well, with the Atlantis software, the application and analysis and I/O processing lets us look at each of these I/O events, the Excel launch versus the AV scan, etc., and do a prioritization and essentially boost the user experience by increasing the priority of any kind of a request that is related to the user experience. And it can deprioritize, events, I/O events that are not as important. For example, the AV processing. If the AV engine took 5 extra seconds to complete the AV scan, it really doesn't matter. And so, we can service, we can deprioritize, we can reprioritize based on our awareness of the workload using these two technologies. Now, inline deduplication is a very interesting area because what we're doing over here is we're taking advantage of the commonality of the data as well as the I/O requests that are generated by all these VDI virtual machines, and we're deduplicating all this I/O on the wire instantly without actually having to write it to storage. So this is two big benefits. Number one, whatever is written down as storage is automatically deduplicated, only written to storage after it's deduplicated. So it only takes a small fraction of the space that it would normally. And the second thing that it does is it actually removes the storage, removes the IOP from going to storage, so it has an offloading effect. So the Atlantis ILIO software is able to deliver 50,000 IOPS to the VMs that are running against it. Yet from the storage system itself, from the background storage, it takes a very nominal few hundred IOPS to actually just commit data down from the active memory down to the storage system. And that's a function of the deduplication. Once data gets deduplicated, it further gets compressed. And as a result of that, we're able to take huge, humongous VMs and store them on very small amounts of memory. We can take an 80 gigabyte full clone virtual machine and store that, and shrink and deduplicate it and compress it down to under 1.5 gigs typically. So massive reduction using these two transformations. And then we store this all on memory, from where we continuously replicate it down to the physical storage layer. So that's what's happening from the active memory down to the physical storage. Anything that's changing is continuously synchronized back. So if you ever lose power for whatever reason, or if the blade server, this rack server that you're deployed this on fails, you don't lose any data. All the data is continuously backed up and is available on storage. So it's a combination of these 5 transformations that allow us to now take RAM and make it into a storage element and allow that RAM to actually become the primary storage for your VDI. This now allows you to have full persistent VDI desktops that would conventional storage technologies would require just a humongous amount of storage capacity and I/O. Instead, we're using algorithms to amplify the capacity of RAM, and then we're taking advantage of the inherent speed of RAM to deliver the performance. So it's really a great marriage of two technologies, the reliability of storage along with the performance of RAM, with smart algorithms to turn it into a whole new type of storage. So we've done a lot of benchmarking, and one of the benchmarks that is heavily used in the PC world is something called Passmark, which most of the magazines and top blog sites that review hardware use. And what we have done is we've used the same exact methodology for benchmarking and found that the Atlantis ILIO software has scored some of the highest performance benchmarks. This is the first time that a VDI machine has actually been rated in the top 5 systems in the world. it's faster than most conventional systems because it has one of the highest scores out there. And you know, a score of 5,534 places the Atlantis VDI desktop in the top 5 desktops in the world. And by the way, this is something that's not been done in a specially configured lab. This is sort of, you know, fairly average for most implementations that use this technology. You get the same consistent user, high performance user experience when you deploy it, because the speed of RAM is the same anywhere in the world. So in this particular graph, we're looking at disk ratings from Passmark. It shows the Apple SSD, which powers a MacBook Air in the top 20, and then it shows the Intel SSD slightly faster than that, and then up there in the top 5 is the Atlantis in-memory VDI with a score of 5,534. So I'll cover one last technical piece and you know, bring it in for summaries and then Q&A. How does this technology actually deploy? What does the architecture look like? Well, it's very, very simple. What I have over here is a picture that represents a typical VDI deployment. You've got a bunch of servers. These could be blades, these could be racks. You install a copy of the Atlantis software on each of those servers. In fact, we have an automation tool that we call deployment services that will simplify the deployment of the desktops as well as the Atlantis software for you. But net, we have a copy of the Atlantis ILIO software installed on each of these hosts, and that software will take the local RAM and turn that into storage against which your VMs will run. So as the VMs are running, they're performing all their I/O against this RAM. It's all extremely fast because it's staying within the host. Now, in the background, each of these ILIOs is synchronizing with storage through a special purpose ILIO software called a replication instance. So there's a host, there's a replication instance of the Atlantis ILIO software that could be on your management infrastructure, or it could be dedicated to its own host. And what that is doing is it's continuously taking the content of memory and writing it down in your physical storage. And so you're getting the durability of storage because everything goes down to storage, but at the same time, you're getting this high performance because everything is coming off local RAM itself. So all's great, but what happens if there's a failure? So we recommend that you deploy HA, and we leverage VMware HA extensively in VMware environments with an N+1 configuration. That means that you have one standby host that's configured as a part of this cluster, and so if you have one of those VDI hosts fail, then VMware HA simply restarts the Atlantis ILIO software along with the desktops on this failover host and restores service. And the same thing happens if you lose, for example, the host that's running one of your Atlantis ILIO replication instances that's taking the contents of memory and writing it to storage. I'll give you one quick example. We've done extensive benchmarking, especially using an industry standard tool called Login VSI by the Login Consultants Group. This VSI benchmarking tool is really one of the best ways that you can go out and try to assess what the capacity and the performance of VDI deployment and your infrastructure will be. So what we did was we built a 10 host cluster where each of these hosts would run a copy of the Atlantis software along with the desktops. Each of these hosts was given 192 gigs of RAM, and the hosts had 12 cores on them, which were about 2.93 gigahertz each. And on them we put Windows 7 desktops, which were given 2 gigs of RAM. And we created an Atlantis ILIO appliance that took 40 of the 192 gigs of physical memory on that host and turned that into storage. And we also give that Atlantis ILIO instance 2 vCPUs. We also took one additional server and put a replication instance of the software on it, and we gave that as a replication instance of Atlantis ILIO 30 gigs of RAM and 2 vCPUs. And we connected it in the back end to a NAS, to a NetApp NAS, where we had set up a 9-disk aggregate. Each of these disks is a 15K SAS drive that we had put together with RAID DP. And the cumulative capacity that we had, the cumulative capacity across all 9 drives was 400 gigabytes. So just 9 drives, and we were able to put 750 users. But here's the interesting thing. As we ran VSI while increasing the load of users, what you'll find is the performance is extremely consistent. That's the blue line over there showing the VSI average response. At 56 users, when we first started to measure, you have the VSI average response hugging the 1,000 mark, which is a really great response time. In VSI, anything under 4,000 is considered great, so we're really, really at the top end of performance. performance over here. But here's the interesting thing. As you scale up through 330 users to 612, all the way to 750, there's a marginal increase, from 1,000 to 1,200 in terms of the response time, which means that the system can really scale very, very well. With just 9 drives, with no flash, just using the Atlantis persistent VDI software that turns RAM into storage, we were able to run login VSI with probably what is one of the best scores out there for login VSI. And if you want to compare that to some of the other VSI benchmarks that have been done by organizations like Citrix and NetApp, this is something comparable. This is only different in the number of users. So they're testing across 2,000 users while we tested against 750. But here's what I want you to note. As the system runs with just 100 users logged in, the response time is already at 2,000, whereas with Atlantis, the response time was starting at 1,000. Now, as you get to 700, 750, 800, you're still at 2,000. And then as it starts to load up, you find that the response time goes all the way to 4,000 and fails. But here's the shocker. This is a system that has 96 drives on it, whereas the Atlantis ILIO system was just 9 drives. So you're talking about the Atlantis system with 18 drives completely outperforming this sort of configuration, alternate configuration. And by the way, this storage system is 96 SAS drives with 256 gigs of flash. So this is not exactly a cheap commodity storage system. This is an expensive, high-end NAS storage system, and the Atlantis ILIO just uses commodity commodity hardware to completely outperform this kind of expensive enterprise infrastructure. So last bit. Software is extremely transformative because of what it does in the storage, but it also comes with a full set of automation. So you can do automated, multi-rack, multi-data center deployments. The software is intelligent enough to automatically size and configure itself. It will also automate the data store creation of the NFS data stores that the Atlantis ILIO VM creates. And then you basically go into VMware View, or you go into Citrix MCS, PVS, and provision your desktops over there. So in summary, when you take RAM that's available on a server and turn that into storage using Atlantis ILIO, you get 2 incredible things that have never been possible before. You get an affordable virtual desktop, a virtual desktop that's persistent and yet cheaper than a PC, with better than PC user experience. So, for the first time in history, really these 2 words have been used in data centers and storage together, cheap and fast. And that's really because of this technology. You also get enterprise-class features like HANDR and automation that eliminates risks and gives you a consistent, scalable model. So with that, ladies and gentlemen, and bring your attention to some of the resources that we have on the Atlantis website. You can request a trial copy of the software by visiting our website. You can also look at videos that show you the VDI user experience demonstration, and as well as get reference architectures for how various vendors have partnered with us to deliver VDI persistent VDI solutions, as well as a podcast on how to deliver ILIO persistent VDI. So with that, let me bring it back to Seth. Over to you, Seth.
Yeah, so we have, if you have any questions that you'd like to ask Chetan with the remaining time, please enter them into the question box. We already have some coming in, so let me pose the question to Chetan, and we'll get into a little discussion with the 10 minutes we have left. The first question is around vMotion. So you showed the architecture of have in-memory data stores on each of the session hosts, and you have a replication host. Can you explain how vMotion works and what happens with the contents of the memory in the case of a vMotion?
That's a great question, and I'll answer this very simply. In that, vMotion DRS, they're all fully supported in the Atlantis ILIO persistent VDI architecture. You can cross-mount the data stores that various ILIOs provide to other hosts. We also provide a set of affinity rules that allow us to hint to DRS how to keep VMs that belong to a specific ILIO data store together on the same host. We want to do that so that we can leverage the speed that is available when VMs communicate to the data store, the ILIO data store, while remaining on the same host, without needing to switch out to the physical network and go across the physical network layer. By eliminating the need to go to the physical network layer, you can essentially get better than 10 gig speeds within the host, and we like to take advantage of that. And the best way to take advantage of that, along with vMotion and DRS, is to use a set of standard affinity rules that we provide. And that now gives you the ability to leverage DRS, vMotion, all the tools that you're used to using, that you love VMware for, along with this particular architecture. So it all just simply works together and works well together.
Okay, thanks, Chetan. Another question is, can you give some idea of the amount of RAM? Because some people, you hear RAM, you typically think, oh, that might be expensive, but, talk a little bit more about the sizing, and you showed one architecture there where we did the login VSI test, but people are interested in kind of the rules of thumb on the amount of RAM.
Sure. So the rules of thumb around how much RAM that you need to allocate really boil down to, I think, 2 or 3 factors. Number one factor, what is the size of your image or your persistent VDI, your persistent desktop? And I would recommend that you try and streamline that to some extent, to whatever extent possible, by eliminating unnecessary components and necessary applications, etc. Number 2, it's the amount of unique user data that every user generates. So, for example, if you're using local profile and you're not storing anything on the network, the second aspect of how you size is really related to how much of unique data users will generate. But in general, what we like to provide, what we have seen through various implementations, as well as sizable deployments. We have customers who have deployed tens of thousands of these in a single site. What we found is that by giving the ILIO, by sizing the ILIO, with each user having a full allocation of about 10 gigabytes to 15 gigabytes of data, as well as an operating system image of 40 gigabytes to 50 gigabytes, you can essentially put all of this together in an ILIO appliance that is given about 100 gigs of RAM. So in a 256 gig server, 100 gigs of that 256 gigs is given to the Atlantis ILIO. The remaining 156 is given to the VMs as their physical memory. We recommend you slightly overcommit the memory of the VMs, and this is fine because overcommitting only means that you're going to be swapping more. But the benefit over here is that you're swapping onto an ILIO that is basically using RAM as storage. The swapping has really very little penalty, and so you can get upwards of 100 VMs per host, along with the Atlantis ILIO taking 100 gigs of storage, 100 gigs of RAM as storage on a 256 gig host. So roughly, I'd say that on a 192 gig host, you can get to about 60 users per host, along with the Atlantis software. On 256 gig, you can get to about 80, top side about 100, but I'd size for about 80. And on a 384 gig host, you can get to about 120 to 140 users.
Okay, thank you, Chetan. A follow-up, have you seen, that's related to the amount of RAM, have you seen customers adding RAM to each server, or have you looked at configurations where they've been able to overcommit or do some of the things where you can kind of efficiently use an existing deployment? Like basically, does it take a new server with a lot of RAM, or can you do this in an existing environment where you have VDI deployed?
No, so if you're a brownfield deployment, you already have a VDI and you're interested in taking advantage of Atlantis ILIO, and say for whatever reason you've got a server that only has a 98 gigs of RAM on it, well, what Atlantis ILIO can do is it can actually leverage local flash. So if you can, instead of buying more RAM, install local PCI Express flash, then it can use that flash as a substitute for DDR3 memory. And the performance differential or delta is negligible from a user experience standpoint, but that now allows you to, without the need to upgrade the memory capacity of your servers because you might not have enough slots in there, or whatever reasons, incompatibility, BIOS, etc., completely sidestep that by using local flash and scale out using that model. But what we've seen is a typical VDI deployment, usually has servers that are 192 to 256 gigs of RAM. So in most cases, there's enough horsepower already in your environment for you to deploy the Atlantis ILIO software without needing to do new things to it.
Yeah, the other thing I'd add is that in doing a lot of cost analysis with customers, when the price of RAM on new servers is dramatically dropped, the 16 gig DIMMs are now kind of the standard and sweet spot. So 256, 384, or even 512 is very affordable relative to the alternate cost of doing a lot of purchasing a lot of sand, which would be much more expensive. We've seen as low street price of $10 per gigabyte in RAM, and you only need a very small amount of that per user. So it's a very low cost after the optimization of the RAM, the compression, the inline deduplication.
Yep, great with that. Yeah.
Okay, let me see if we have any more questions. If not, we will wrap it up. I think that's it. And well, thank you for attending. A reminder, you'll receive a link with a recording within the next couple of days. We will post the presentation slides on the Atlantis Computing website under Resources, Company Resources. And thank you for attending. We have our next webinar will be about XenApp, and we had some questions about XenApp on the call today. We'll actually be featuring a customer and a partner named Kelway, who was able to deploy XenApp and scale their XenApp infrastructure by using a similar technology to this in persistent VDI. So we welcome you to join us on that one if you have XenApp implementations. Thank you, and we will close the webinar now.
Thanks.